Selamat sejahtera to Dr. Azhar. We are from Group 9 Section 5. Our video are going to present our design of AC to DC converter. Our video is divided into 4 parts, which is transformer, rectifier circuit, filter circuit, and voltage regulator circuit. I'm Chuyin. Now I'm going to further explaining on my part, which is about the design of transformer. The transformer are not available in the LT-Spice gallery. However, we can easily model two inductors into transformer by adding directive statement K to couple the windings. The syntax shown here, K is the directive statement, L1 and L2 is the primary and the secondary inductors, and the value of 1 here is showing the mutual coupling coefficient is to prevent any leakage of the inductance. And we set the voltage source into 240 volt RMS, and the other hand we also set the first inductance into 400 millihenry, and the second inductance is 1 millihenry. And we also adding 2 resistors into the circuit. The first one is added to the primary circuit, which is 0.0 milliohm to the sources to break the continuous loop between the source and the L1. And the second one is the 1000 ohm of resistor is added to the secondary circuit to prevent any errors while we stimulate the circuit. Now I'm going to run the result. This is the result. We can click any of this corner to show the output and the input voltage. The green one is the input voltage and the blue one is the output voltage. We can click this green cursor to show us the exact value of the input voltage. Our input voltage is around 339 watt and our output voltage is around 16.96 watt. Now I'm going to pass the presentation to the next person.
Now I'm going to continue the presentation by introducing the second part of AC to DC power supply. So the second part of the AC to DC power supply is the rectifier. So as you can see, this is the setup of full wave bridge rectifier. So the rectifier consists of 4 diodes and each diode has 0.7 mV voltage because it is a silicon diode. So the function of the rectifier is convert AC to pulsating DC. So during the positive cycle, the D2 and D3 diode will become forward bias, and during the negative cycle, the D1 and D4 diode will become forward bias. So now let's come to the simulation. So as you can see, this is the positive half cycle, and this is the negative half cycle. So this is the final output of the pulsating DC. So as you can see, this final output is 15.59, which is similar to the result of the calculation. And this voltage experienced 1.4 voltage drop because of the diode.
After convert the AC to pulsating DC, now we move to the third part of our AC to DC converter, which is the filter. The filter is a capacitor which placed parallel to the load resistor, and the function of the capacitor is to convert the pulsating DC to smooth DC with ripple by charging up at the peak and discharge steadily after the peak. And now we simulate this circuit. As we can see from the graph, the pulsating DC now is changed to the smooth DC with ripple. And we can calculate the peak-to-peak ripple voltage by applying the formula peak output voltage divided by 2F RLC. We can get the minimum output voltage by subtracting the peak-to-peak output voltage from the peak output voltage.
Hello, Dr. Azhar. My name is Wong Wei Heng. Today I'm going to further explain on my part, which is Zener regulator. Zener regulator is used to convert smooth DC into constant DC. Zener regulator is made by Zener diode. For this circuit, we use Zener diode, which is 1N750, which will give us around 4.7 of Zener voltage. Let's run the simulation and see. And we measure the output voltage, and we enable the cursor, and we found that the output voltage is around 4.74, which expected. That's all for us. Thank you.